Alrighty, our gorgeous 8th graders. This is our 7.2 lesson, equations with rational numbers. Our standard and then objective is that you should be able to solve equations with rational numbers, coefficients, and constants with an 80% accuracy given your homework. Just remembering that rational numbers are basically numbers that can be written as a ratio of A over B. Okay, so most of the numbers that we know are rational numbers. So for instance, 1/4 is a rational number, right? Or if I have, like, for instance, 3.5, I can rewrite that as 7/2. So all those are rational numbers. Coefficients, okay, so coefficients will be like, for instance, if I have this right here, this whole is a thing is a term, so separated with a plus sign by another term. This right here is my variable, this is my coefficient, and this is my constant. Okay, any number doesn't have any variable close, next to it, that's a constant. But if it does have a variable to it, we have a variable and our coefficient. Okay, so I'm going to erase that. Let's solve. So this one first is solving with fractions. So the first thing you're going to do with fractions is to make it easier on you, instead of just adding and subtracting all those fractions, you're going to look at that should be it too right there. You're gonna look at the denominators that you have in the equation. Okay, so I have 10, I have 2, and I have 5. So I need to find the LCM. So going back to 6th grade, I need to see which is the first number that comes up in those three multiplication tables, and the LCM for 10, 2, and 5 is 10. If you don't remember how to do that, I can start with 10. So 10 can by 10, 10, 20, 30, right? And then 5, 5, 10. I already see the 10 there. And then if I count by 2, it's 2, 4, 6, 8, 10. So 10 is my first number multiple that appears in those three. So what I'm going to do is I'm going to multiply the whole thing by 10. Okay? So I'm going to multiply. So let me bring it down so you guys can see that. So I'm going to do parentheses there, and I'm going to multiply the whole thing times 10, and I'm going to multiply this times 10 as well. Remember, when we're multiplying by a whole number, I basically put a 1 under it, okay? So I'm just going to show you here what's happening. So if I multiply, and I'm going to have to multiply to each of those terms, okay? So I'm basically saying 10 times 7 over 10 times n, okay? So basically, I multiply straight across, so that will be 70 over 10 n. What's 70 divided by 10? 7, so that's 7n, okay? Right here, I have 10 over 1 times 3 over 2, right? So 10 times 3 is 30, and 2 times 1 is 2, and that gives me 15. So plus 15. Okay, I'm going to bring the same symbol there, and I'm going to say equal to, and then right here I have 10 over 1 times 3 over 5. If I multiply straight across, that's going to give me 30 over 5, and then what's an n here? So then I have 30 divided by 6 is, 30 divided by 5 is 6, so 6n. And lastly, I'm going to multiply by this term right here. So 10 over 1 times 2 over 1, right? And that is 20 divided by 1, which is 20. So plus 20. Okay, so now I don't have this crazy mess, and I have this right here. Now remember, we're going to combine like terms. So I'm going to move all my n's to one side and all the constants to the other side. I don't like dealing with negatives, so again, I'm going to strategize, and I'm going to move my 6n to the other side. So to move it, I have to do the inverse operation, which is to subtract. So I'm going to do minus 6n minus 6n. This cancels out. 7n minus 6n is just 1n. Bring down my plus 15 equals 20. Now I'm almost there. So I did the first step. Second step, I need to move the 15 to the other side. So I have to subtract 15 to both sides. So then I bring down my n equals 20 minus 15 is just 5. So then I have my answer right there. And again, I can plug it in to check my my answer to see if it's correct. Okay, so that is with fractions. Again, that's the easiest way to do it, to find the LCM. And then you remember, you multiply each of those terms by that to get your whole numbers out. Okay, so I'm going to erase that, and I'm going to get back to the decimal ones. Again, I want to get all the x's on one side and all the constants to the other side. Now I see that the x is already here, and I don't have anything else there, so I'm going to move this one to the other side. What I do to one side, I have to do to the other side. This cancels out. I bring down my 75 hundredths equals 0.5 minus 0.2 is basically 0.3x. And that's my first step. The second step is because I'm multiplying the 3/10 by the x, I have to do the opposite, which is division. So I'm going to divide both sides by 0.3 by 0.3. And remember, first one goes inside the house. And remember, I cannot have a decimal as my divisor, so I need to move that to the right one time. And what I do to the outside, I have to do to the inside. So then I end up with I end up with 7.5 divided by 3. How many times is 3 going to 7? Twice, and I have 1 left. Bring up my decimal, and then I bring down my 5. How many times is 3 going to 15? 5 times. 5 times 3 is 15, so I have a remainder of 0. So therefore, 2.5 equals 2x. Or x equals to 2.5, and I'm done. Okay? Now, writing a real world situation from an equation. So for instance, if I have 1.25x equals 0.75x plus 2. Okay? So I can come up with a problem that, for instance, says you go to the store. There's store A has collection cards. I don't know. So we have cards for $1.25 each. Okay, so you're paying that. Now there's a store B where you pay 75 cents for each card, but you have to pay a $2 membership fee. Okay, so again, store A, you buy each of the collection cards for $1.25. Store B, you're buying every card for 75 cents each, and you're paying a $2 membership just to be part of that club or group of people that can buy the cards for 75 cents. The real world situation will be how many cards will you need to buy, right? To make the cost the same. So for instance, you're gonna say, so how many cards do I need to buy? Where what I pay in store A is going to be equal to store B. And you don't have to solve it, but let me just solve it for you so you can see. Again, I'm going to move my x's to the other side because I want to combine like terms, and those are like terms. So then I end up with 0.50x equals 2, divide by 0.5, divide by 0.5, x equals to 4. And so in this case, the solution will be 4. That means that if you buy 4 cards, in store A or 4 cards in store B, it doesn't make a difference because you're going to be ending paying the same amount of money. Okay? Remember, math is magical. You're amazing. You can do this. You got this. God bless you. Bye-bye.